Oh,
Our
okay.
last presentation of this session, which comes from Dr. Gord Lovegrove, who is an expert in sustainable transportation, infrastructure, community development, road safety, and Hydrail, which is hydrogen fuel cell battery hybrid rail power. He helped launch the School of Engineering at the University of British Columbia, Okanagan in 2005, where he now serves as an associate professor of sustainable communities. He has also served as an expert witness and internationally recognized consultant on sustainable development and transport safety, and on national and international committees, including as vice president of the technical programs for the Canadian Society for Civil Engineering. Join me in welcoming Gord.
Hi, everybody. Kevin, is the screen all good?
It looks good on my end.
Excellent. I'll jump right in. Time is short. Thanks, everybody. And I just want to acknowledge where I'm sitting right now. Normally, it would be the traditional territory, unceded territory of Silks Okanagan Nation. I'm actually down in Cathedral, California, Cathedral City. And that, if you go back, is Cahuilla Nation territories. I just want to acknowledge that. And I think it's important to acknowledge, just like our previous speakers, a system approach in every respect. And I know this theme of this session is climate responses to climate change and how we can adapt and what we do. And so I want to just, in my presentation, continue on that theme. And I just thank you, everyone, for welcoming me here and hosting this conference. I think it's been great. I'm looking forward to the rest of it. And at UBC, indeed, we are looking at a zero-emission future. This is the way we have to go if we're going to leave a future for our children and others to inherit that they can thrive in, just like we have been in the past. And so it's exciting. Canada's hydrogen strategy was announced in 2020. So we know we're going there, but how do we raise a sector simultaneously? There's a hydrogen hub in Edmonton. We're looking at something similar in the Okanagan Valley here. And so my area, as a node lead, will be in application. So we've heard a lot of that. The research, starting off with a great inspirational leadership talk and right through all the technology and research. And then in my area, one of the things I want to talk about is embedded in that hydrogen strategy, the national hydrogen strategy, was the need to have demonstration projects and what we're doing. So we're, it's going to involve some investments, and of course nobody's going to come near anybody unless there's some sort of a business case or research done. So that's one of the areas I have is researching and creating the business case, so to speak, for that. Now, I just want to show this. I know time is tight. This is kind of what we're doing in the paper. You can read it all. This is being recorded, so please forgive me for the 50,000 high-speed flyover, but this is, and actually, I think I need to share sound and optimize for video clip. So let me see if this works, and if it doesn't, I apologize. There we go. Let's try. And interrupt me if it's not working right, but I think this should work.
Researchers at UBC Okanagan Sustainable Transport Safety Lab and the School of Engineering are working to retrofit a diesel-electric switcher locomotive to be powered by hydrogen fuel cells. The Green Goat switcher locomotive sports a hybrid powertrain. A small diesel engine turns a generator, which connects to a bank of batteries that power DC traction motors. This makes this locomotive an ideal candidate for the retrofit. To streamline the conversion process, the original DC traction motors will be kept. The lead-acid batteries, diesel engine, and generator will be replaced with hydrogen fuel cells, newer lithium-ion cells of a chemistry and capacity appropriate for the desired duty cycle. The stock Green Goat locomotive gets the bulk of its power from its bank of lead-acid batteries, which send DC power directly to the motors. Diesel fuel is used to extend the range of the vehicle and powers a small genset which charges the batteries. Once it is converted to run on hydrogen, bulk power will be supplied by its fuel cells. The batteries can be charged by the fuel cells and provide a load to regulate the power output. They can also power the motors directly during peak or instant demands that the fuel cells alone cannot meet. The Green Goat hydrogen power retrofit is an important proof of concept, vital for the timely implementation of Canada's proposed hydrogen strategy. If successful, it will open the door to the development of an industry around hydrogen retrofits which will be part of a greater hydrogen-based economy. The STS Lab is working with industry partners on so many projects aimed on nurturing such an economy. The lab's first hydrogen-powered fuel cell retrofit, the Hydrail 1, is now being tested. It will provide valuable insights for the hydrogen green goat retrofit. They have also worked on the Okanagan Hydrail proposal for a hydrogen-powered electric railway through the Okanagan Valley and green hydrogen production through solar-powered electrolysis, as well as innovations in hydrogen storage.
I just want to acknowledge that we also receive funding, as you can see there, from NSERC, CFI Innovation Canada, Transport Canada. Our industry partners on this project are SRY, Southern Railway BC, as well as the Hydrogen in Motion folks. So it's and so we've got a team. We've been working on this for a couple of years. We're gonna, well, it's clearly already been on the rail. It's an old green goat retrofit, but we expect that to have be retrofitted and up for testing within the next year. And that's what it looks like now, and that's where it's going. And these are the major work packages. And I just, by way of introduction, that's where we're going. And we've just confirmed 2 master's students to help Higazi Mohammed, my PhD candidate student, and we're moving forward. We've had a lot of good industry partnerships, and we're building on those to go forward. And so now to the business case, and Karina, I really appreciate your comments, and that's why I asked the very pointed question: what the heck are you thinking running rail in rural, low density areas? And that's what, because that's the question I'm getting asked. What the heck are you thinking, Lovegrove, that you can run a rail, a passenger rail, not just because there's no highway, but on or beside a highway in a low density rural area? And in fact, there's been news controversy about it on the radio and et cetera, about, oh, it's not SkyTrain. The densities are too low. So anyways, there's the paper that we've submitted for publication. It goes into a lot more depth. What I'm presenting is more or less a hint. It's going to salt your or whet your appetite for more. So the real 2 questions are, research wise, is it technically feasible? Will this thing run on a grade? Because we've heard already folks say typically along rivers and lakes is where it should go. Nope. There's technology out there, as Karina's already said. It's evolving so fast. We're no longer bound. The route is not a constraint anymore. We have total route flexibility. And then economic, once you get past the technical feasibility, is it economically feasible? So we are looking at a vehicle similar to, but not identical to, the Grady Island. It's been running for several years in commercial service, run by government, not privately, arm's length, you might say Crown Corporation in Germany, in the Holstein-Saxony province. And we're looking at something similar. The snapshot I took would use embedded rails in cities and probably beside the highway, down the median, embedded rails in cities, and then in some sort of rail right away beside or in the median, the highway between cities. And clearly it would be running at city speeds in cities and highway speeds between cities. So we're at that, assuming a similar type vehicle, we're looking at if we had 1,000 kilowatt horsepower, all axles powered, assuming a 50% hydrogen fuel cell efficiency. So these things are a hydrogen fuel cell being used to charge the batteries. Per trip, 2,400 kilowatt hours. And so per day, hydrogen storage at a low pressure, this is where Hydrogen in Motion, a key industry partner, comes in, 150 kilograms of hydrogen. And so the route we're looking at, and again, this is conceptual, so theoretical, it's got rail existing from Kelowna, or it used to from Kelowna. Now it's Vernon north to Kamloops. It's got a rail bed from Kelowna to Vernon, and it has, you could argue, old rail bed for part of the way down to the US border. And the key here is connecting to the networks, the Canadian network at Kamloops and the American network down south of the border. The maximum elevation, get this, maximum grade, I should say, 10% ruling grade, some sections of Highway 97. And yet, technically, this thing can make that not a problem. Hey, if SkyTrain can do it with its powered axles, why can't we? And single track to start, passing sidings at stations or on demand as the ridership grows, as frequency increases, with 13 stations. Some of the work we've done, Higazi's done this as part of his PhD. Simple, very, I can't remember the software, starts with a V. Anyways, the ride, a single vehicle pass bys in each direction, give us the effort needed, resistive forces, et cetera, for a duty cycle, and that's where you come up with it. Some work done over 10 years ago by one of my earlier master students on ridership. And really the secret sauce to all this, we've been very conservative in all our estimates, has been connecting to the networks. As Karina pointed out in the answer to my question, we see millennials not driving as much anymore. In fact, they're choosing not to renew. So we know there's ecotourism, there's seniors, there's international tourists. And just think of yourself when you go to international tourist destinations, especially all across Europe, tram-trains, trams in cities, rail, intercity travel is where the great tourist destinations go, and the Okanagan is another one of those meccas. We did test everything though, conservative, optimistic, pessimistic, and expected values. We had a walkthrough, drive-through with a professional, one of Western Canada's leading rail contractors. And given all of that, I'm going to pause here. A lot of numbers, a lot of words, violating every presentation rule I've ever used on this page. You can scan through it, but with a net present value calculation, assuming a 6% discount rate, which we lowered down to 2, went up to 10 with over 30 years, 2021 base year dollars, and all the other assumptions you can see in there. It's just ridiculous. The benefit cost ratio, it's unbelievable. And of course, we say when something seems too good to be true, it generally is, but we also use the province of BC business case template to do this analysis. And when we compare the two, we see their benefit cost ratio is up at around 5.5. We've got it at 7. And then we went beyond that. We said, well, hold on, let's combine all this with a Monte Carlo simulation, and 95% of our trials showed a net present value of almost $7 billion with a benefit cost ratio of over 3. So, you know what? When we talk about the two and climate change, there's externalities, right? We need to internalize those externalities. And one of them is reducing greenhouse gas emissions, reducing the risk of people killing themselves in these fatal crashes, and also increasing transport equity. So a lot of UN Sustainable Development Goals, the 17 Sustainable Development Goals, are being met by this technology. And so we've got very similar outcome. We tend to, I'm biased, say that actually this rail augments the system. It addresses many system issues. And so, yes, there are limitations to it. We have not got a final engineering design, because one of the things is, as you can see in the next steps, we actually have to talk to the residents, the communities. We have partnered and talked to a lot of the mayors and the First Nations, as I said, in the Valley already. They're quite excited about that. But of course, a business case, understanding the distribution of costs and benefits and who pays what, and federal and provincial and local partnerships is going to be a huge discussion, with heavy lifting done by a private P3 partner. We know that. And so there's a lot of things still to be done, but early results are extremely promising. And we can do this. We just really need some strong leadership. And I think that's the key. Is next steps is we need to decide, are we really interested? Are we really committed, as our previous speaker just said, to leaving a future for the next generation? So thank you very much for your time. I know we're late, so probably don't have any time for questions. Although, hey, I made up some time for you, Kevin. Look at that. I'll stop there.
Yeah, you did great out there. I mean, we can take 1 or 2 questions here if there is some from the chat, or if anyone wants to raise their hand and I can unmute you so you can ask a question to Gord. We'll give it a second here. But yeah, thank you for that. I think I saw Wolf. There we go. It disappeared. But yeah, thanks for that. It's always interesting to hear about hydrogen technologies, because the understanding of it, people want cars to go that way first, but I think rail or long haul type systems is what it's more ready for at the moment, right? So it's always nice to see that this is research that's being conducted and being really thought out.
Yeah, we have presentations on exactly that, Kevin. I wanted to be this more of a economic business case overview, but absolutely there's a ton of theoretical technology background as well. The paper will go into that technical feasibility aspect. You're absolutely right. We have theses on the shelf about that. So thanks for that comment.